Hello, welcome. Let's take a different turn on the series we are doing on static mechanics. The first 12 episodes were built on the concept and frictional force with each coefficient. Now we want to take forces, each representation, and the resolution of what forces in this episode. So, just a recap on the things we have said so far from the beginning. So, a force is a vector. So, a force as a vector is just a force which is necessary to cause a body to accelerate, as in to move, to cause a motion of a body. So, more than one forces may act on a body. We talk about that tensional force, normal reaction. There could be a push, there could be a pull, there could be a weight also on the body. There are so many forces. So more than one can be acting. So if the forces are in equilibrium, meaning they balances each other, then the body may be at rest. There will be no motion, no acceleration, no movement. All right. So if there is a resultant force, a particular force that destabilizes the balance, that causing one side to be bigger than the other, then the body will accelerate. That is the only point by which the body will move. So if the gravitational pull on the body is bigger than the frictional force, definitely the body will slide down. But if you have a push that is bigger than the friction, the body also move. That is an acceleration. So the force F, which is acting on a body which is having a mass of m, moving with an acceleration of a, is given by the relation. So how will I find the force? Apart from the calculations we did under friction, normal force, to find the force acting on a particular body, it means that the mass of the body in connection with the force of gravity, that gives us the force. So the acceleration due to gravity times the mass will give you the force. So the force is just m times what? A, where m is in gram, a is in meter per second square. Both combined will give you the SI unit of force to be Newton, capital N. All right. Now let's see how we can represent forces also. Let's see. In the representation of forces, we learn from the beginning that forces that are given as a definition of vector, it has both magnitude and what? Direction. So if a force acting on a point may be represented by its magnitude and its direction in this form, then this particular form, the force in this form, can also be expressed in other forms, which we can call as column vector, or a column form, or component form, or better still, column vector form. Then we can also have what they call the Cartesian coordinate form, which is the the IJ system. So it is in the form as xi plus yj, where the I and j are the unit vectors in the x and y direction. So in this form, to be able to translate this to this form or this form is what we are calling resolution of what? Forces. That is resolution of what? Forces. Okay, so let's see. If we want to represent this, we know a force has a magnitude, has a direction from the bearing. So let's make a sketch of our Cartesian plane. Let's make the origin a force acting in this direction. Can we use F? Let's just say force P acting in this direction. It is going to have the north pole. We have angle theta, let's say angle alpha. Now these are the two angles which show the direction of the force. Now we can see that the alpha is, let's say we let this to be x component or the horizontal component, which is the north. We can also call it what? The y component, which is the vertical component. Now this alpha is the direction of the force in the anti-clockwise direction, or the angle in the anti-clockwise direction that the force makes with the x-axis. That is that force. Then the theta is also the force measured from the north. The force that the direction that the force make measuring from the north. So these are two forces that we have in this place. Now, if we can introduce parallel lines, can we use some parallel lines? Let's say we have this line being parallel to the vertical one, x component, and this line also being parallel to that. I can say that this will be 90 because this is parallel to this, and this is parallel to this will also give us what? 90 degrees. And this will show, if I am measuring from here to here, I should be measuring what? Y. If I am measuring from here to here, I should be measuring x. Since this form a quadrilateral that have all the sides, this being equal to this, it becomes a rectangle. So this will also be x, and this will also be what? Y. Now we want to find the x and y component, where in this case we are only having the force, which is this is the magnitude. We have the magnitude, we have the direction in these two forms. How do we represent the x component and the y component? Because this is x, this is y. We need to write it in terms of the p, which is the magnitude, and the theta or the alpha, which is the direction, the angle in bearing form. Now, you can see that if we represent, let's say 30 Newton still in 30 degrees. This is an example of a force. That is for a force acting force of for 30 in the direction of what? 30 degrees, or on the bearing of 30. This is what we mean. On the bearing of 30 means you need to measure from the North Pole. So it will be easy to say this than to say that a force acting 30 Newton, which is what? In the anti-clockwise direction, 60 degrees with the x-axis. Because if we are measuring from the top, theta 30, it means that when I want to describe the angle here, I cannot mention 30. Both two angles are complementary, giving me what? 90 degrees. So this will be 60, 30. So to describe using this angle, I should be mentioning the anti-clockwise movement that the force makes with what? The x-axis. So there are two definitions here. Let's take the first one. Now, if I want to know the x component, and I know this angle, this is right angle triangle. So this will be opposite. I mean, the theta will be opposite here, adjacent. This is hypotenuse. So if I am having this and x opposite hypotenuse, it will be sine theta equals to the opposite side over the hypotenuse. Cross multiply your x will be equals to p sine what? Theta. Then if I want to pick the y in connection with the p, it means the adjacent here opposite hypotenuse, which also give me the cos of the angle theta equals to the adjacent side over the hypotenuse. When you cross multiply, you should be having y equals to, what do we call? P cos what? Theta. So it means that the x component of the force, is going to be P sine theta. So where will I put it? So this here will be labeled as P sine theta. The same way this will be P sine theta. This become okay, let me put the y there as P cos theta. Then this will also be y equals to P cos what? Theta. So now if I want to resolution of the force into the component form or vector component form, it means that I am going to have the x component. Where is the x component? This is the x component, which will be giving me the value of what? P, so I have P sine theta, then the y become what? P cos what? Theta. And this will be equals to our force, the force that we are looking for. So this is being in the bearing of, what do you call it? Magnitude direction form. This is in the component form or column vector form, or the component form. This is how it will be. Now we can also see that if we make use of this, then we need to take care of this out. If I want to make use of that, let me take care of this. No, I think that should be there. Which one do I need? I need this, and this should be there. So y equals to p cos what? Theta. I am looking for this and this. So let me let the x stay in there. Let's take care of this. So now let's make use of the alpha. If I am making use of the angle alpha, this is still the opposite side, the adjacent. This is going to be hypotenuse. So if I am using the alpha opposite hypotenuse, I should be the sine of the angle alpha equals to the opposite side, which is y, then divided by what? Hypotenuse p. When you cross multiply, what happened? The p multiply the sine alpha, right? So it means that this area is going to be sine alpha. Now let's come back to finding this. This is adjacent. This is hypotenuse. So I have cos of alpha equals to adjacent x over p hypotenuse, making your x also equals to p cos what? Theta. So either we have this, don't forget this is the magnitude, so we can indicate magnitude. So this is 1. The second one could also be that the x component is now p, I think this is alpha, p cos alpha. The y component will be p sine alpha. If this is the magnitude, so this vector column equals to vector what? P. So you can see there are two calculations. I would prefer to use the first one, meaning if I have been given 230 degrees in the question, I work with it directly. Because that is a measurement from the north, 230. Apart from that, if I want to use this, it means that I have to calculate the anti-clockwise direction angle that the force is making with the x-axis. So I have to make a diagram, then know the angle makes with the x-axis. That will be a long process. So this can be adopted. This can be used anyway. Both, maybe along the line we'll be using the two, but I'll be using more of this. This is going to be the first one, and this is going to be the second one. So let's see if we take example. So an example like this: express 8 Newton as a bearing of 30 degrees in the column vector form. So in the column vector form, I can only express the force that I am going to pick. That force, let me use F, should be equals to the P, the force given to me, which is 8, then the sine of the angle 30, then 8, the cos of the angle what? 30 degrees. Let's put that in our calculator and see. Okay, so 8 sine 30 will give you 4. Then this 8 cos 30 will also give us 4 root what? 3. These are forces. So, okay, let's put all of them down and indicate the force. So this will be the resolution of forces in the magnitude direction form into the vector component form, or better still, the column form or component form. So this is what you can see. So this is the y component, the x component, which is the horizontal component, then the y component, which is what? The vertical what? Component. All right. Now you can also try the other one, which will be 60. How do you call it? Here is going to be cos 60. So let's see, we have 8 cos 60 will give you 4. 8 cos 60 will give you 4. Then 8 sin 60 will give you 4 root 3. Do you get that? So even though you have changed the position of cos and sine, it is the angle you are changing. If the angle here is 30, the remaining will be what? 60. So we can use that also to get our answer. Now, we can also express this in the Cartesian coordinate form. You might be given the question to resolve this into this form directly. If you are asked to move directly to this form, you still need to come here first before coming here. So in order to write this, it becomes the 4 as the x component. Then we have for the I plus, this is positive, so plus 4 root 3 what? J. That's all. So if you are to express this, this is now in the IJ system, or better still, the Cartesian word, coordinate word form. I guess that is correct. The only thing needed is to add your unit, which is what? Newton. Now, basically in this episode, we just focus on forces, their representation, and how we can resolve the forces into the 3 main components of force. So we can also move from the component form back into the magnitude and what? Bearing form. That will form the basis of the next episode, because this episode is getting longer. Now, I think before we pick that episode also, we will pick a lot of questions that we will test this hypothesis. How we change from magnitude, the distance form, to the vector column form, or to the IJ system. Thanks for watching. Like, share, comment, and subscribe.